I'm an assistant professor at Hunter College in New York, and I'm going to be presenting work that's co-authored with Payal Hathi, who I think is on the call, and Ashish Gupta. Um, so, okay, so this work is about maternal mortality disparities in India. And just a little bit of background on maternal mortality globally, the Sustainable Development Goals call for reducing maternal mortality to fewer than 70 maternal deaths per 100,000 live births by 2030. That date is rapidly approaching, and it's unfortunately unlikely that this goal is going to be met. And part of the reason for that is that in recent years, post-COVID, halted declines and reversals have become evident. So for example, and this is true in rich countries like the US and also in low and middle income countries. So for example, the maternal mortality rate has almost doubled in the US, and gaps between Blacks and whites have widened. So in this context, understanding disparities within populations is very helpful, particularly when we're seeing declines and halted improvements. And understanding disparities within populations can help to inform health policy. So unfortunately, disparities in maternal mortality are very understudied in low and middle income countries. And part of the reason for this is because data linking maternal deaths to social and economic characteristics is scarce. So in this project, we overcome some of these data constraints by using India's Demographic and Health Survey to describe and decompose disparities in maternal mortality by social group, economic status, and geography in India. So India is an important place to study. I don't have to tell you all this because we're having a whole session on India, but it actually, so it has the second largest number of maternal deaths in the world, and it's a highly unequal society. So scheduled castes, scheduled tribes, Muslims, and other backward classes are marginalized in Indian society relative to high caste Hindus. So prior work by my co-authors and I and others has identified disparities in health and also in mortality, life expectancy at birth, along these social dimensions. And health inequalities have also been described by economic status and geography. Okay, so I want to give you guys just a quick preview of our strategy and main findings before I get into the details. So we use the DHS, India's DHS, to estimate the maternal mortality ratio by social group, economic status, and geography. So we're estimating maternal deaths per 100,000 live births. And then we use non-parametric reweighting techniques to decompose the differences in MMR by social group. So we find substantial social disparities. Relative to high caste Hindus, the MMR is more than double among scheduled castes and scheduled tribes, and it's more than 1.5 times larger among Muslims and other backward classes. And the gradient by economic status is particularly steep. MMR among women in the poorest quartile is almost 2.5 times that among women in the richest quartile. By geography, the MMR for rural women is about 1.5 times higher than MMR for urban women. Now, getting to the question of what can explain these differences, differences by social group don't seem to be fully explained by differences in the age patterns of fertility, economic status, or geography. So we see this work contributing to a couple of different streams of literature. First, to a literature on using survey data for maternal mortality estimation, and second, to the very small literature that studies disparities in maternal mortality in low and middle income countries. Okay, so jumping into the data, we use the two most recent rounds of India's nationally representative DHS. Combined, these two data sets collected information on more than 1.4 million women of reproductive age. Enumerators recorded a household roster in the household module, and in that household module, they also asked about deaths of all household members in the 3 to 4 years before the survey. So recent deaths to members of the household. And for deaths of women in their childbearing ages, the respondent was asked whether the woman died during pregnancy, childbirth, or within 2 months after the end of pregnancy or childbirth. And this question really builds off of the World Health Organization's definition for maternal mortality or identifying maternal mortality. Um, so, so information on deaths is coming from the household module, and then information on births is coming from the women's questionnaire. And so all women who are of reproductive ages were surveyed households were interviewed, and they were asked a full birth history. So births were recorded, um, and so, births are coming from this birth history. So using these two modules, we directly estimate maternal mortality rates as maternal deaths per person year. We directly estimate fertility rates as births per person year. And then we divide these to get the maternal mortality ratio. Now, the maternal mortality ratio is normally deaths per 100,000 live births. Why do we, maternal deaths per 100,000 live births. Why do we scale each of these by person years? The reason for that is because each of these, the numerator and denominator, are taken from different survey modules that were collected from different individuals in the household. And so for that reason, in order to sort of make a more apples to apples comparison, we scale each of them by the person years estimated from the same survey module. For inference, we estimate standard errors using the cluster bootstrap method. And so, using this strategy, we are getting all-cause mortality rates and fertility rates for women of their reproductive ages that correspond well to India's official demographic estimates of all-cause mortality and fertility. So the official demographic estimates are coming from India's sample registration system. We also find that the distribution of maternal deaths across ages correspond well to the distribution of maternal deaths across ages in the sample registration system. So this kind of lends some confidence in using this data set and the methods that we're using. Okay, so jumping into our findings, so this figure is showing the estimated MMR by social group. And so what we can see is that for scheduled castes and scheduled tribes, the estimated MMR is about double or more than what we find for high caste Hindus. And for Muslims and women in other backward classes, it's about 1.5 times what we see for high caste Hindus. So there are substantial disparities by social group. So this is displaying maternal mortality, the maternal mortality ratio by wealth quartile. So we estimate a wealth index based on assets owned by the household, and we break up women into we break them up into 4 quartiles. And so what we see is that there's a very steep gradient by wealth. Women in the poorest wealth quartile exhibit a maternal mortality ratio of about 2.5 times women who are in the richest quartile. We also see substantial disparities by urban-rural status. Women living in rural areas exhibit an MMR of about 1.5 times those women living in urban areas. Okay, so let's try to put these findings, these disparities into context a little bit. So the disparities that we're seeing by social group are similar in relative terms to disparities between Blacks and whites in the United States, but they're larger in absolute terms because the maternal mortality ratio is higher in India than in the United States. Also, the disparities by economic status and geography are also similar in relative terms to the US. Okay, so what can help to explain these disparities? So there is an age pattern to the maternal mortality ratio. The risk of death is greater for women who are older. Um, so can differential age patterns of fertility explain differences by SES? And it seems like the answer to that question is no. So even though this graph is plotting age-specific fertility rates. And even though women from these different groups on expectation will have a different number of children, total fertility rates differ. The age pattern of when people are having children is remarkably similar across social group. So it's okay that women from these different groups are having a different number of children because we're scaling by live birth. And what this is showing is that, and the fact that there is an age pattern to MMR probably doesn't well, the age patterns of fertility can't explain the difference between these social groups because they're all having children at about the same time. Of course, parity is something that may be an issue. We don't observe the parity of women who have died. So that's not something that we can explore in this data set. And that's still an open question, that whether parity can help explain this, because we do see differences in total fertility rates across groups. So this graph looks very similar if we look at economic status or urban rural status. Okay, so age patterns of fertility can't explain it. We do know that marginalized groups are poorer than high caste Hindus. So can economic status explain differences by social group? And so in order to explore this, we use a non-parametric reweighting strategy. And so the results of that are shown here in this figure. So for each marginalized group, the first bar is showing the actual difference in MMR between that group and high caste Hindus. And the second bar is showing the gap that remains after accounting for differences in economic status and urban rural residents. And so what we can see is that for most social groups, the gap between that group and high caste Hindus declines once we account for these other differences, but it doesn't fully go away, and all of them are still statistically different. Interestingly, economic status doesn't seem to explain any part of the gap for Muslims. Okay, so differences in economic status and geography don't seem to explain differences by social group. So can differences potentially in maternal health or healthcare access explain differences by social group? And so unfortunately, we don't observe um, the um, the health status or healthcare access among women who've died. But we can observe these characteristics for women who are alive. And based on that comparison, we do see that there are disparities in maternal health and healthcare access by social group, wealth quartile, and geography. And the patterns are particularly steep for different wealth quartiles, and they're a little less steep for social groups. So this does seem to be part of the explanation. So just to summarize, we are finding substantial disparities by these different socioeconomic characteristics. They can't be explained. The social group disparities can't be explained by differences in economic status or geography. Probably healthcare access and maternal nutrition and maternal health play a role. But that's an area that is ripe for future research. So challenging social inequality in health in India is really important for global population health, and we really need to do further research to understand these disparities more. Thank you so much. I'm looking forward to feedback.